Alright, so today we're talking similar polygons. Our I can statements for the day are I can use proportions to identify similar polygons, and I can solve problems using the properties of similar polygons. So, a couple new vocab terms, similar polygons, and what similar polygons are two polygons that are the same shape but different size. And when that happens, the corresponding sides are proportional. So, big picture here, proportional sides we can calculate using proportions or ratios. Dealer's choice, really. And the scale factor is the ratio of one side to the corresponding side of a similar polygon. So, those are both kind of big deals in what we're doing today. So, similar polygons, like we just said, two polygons are similar if and only if their corresponding angles are congruent and the corresponding side lengths are proportional. So I really like the graphic here because it highlights how we can write our similarity statements using just the way that phrasing. So the similarity statements here are kind of highlighted by the colors that they used. So A is black, that corresponds to W, which is black. B is red, X is red, C is blue, Y is blue, D is green, Z is green. So all those correspond to each other in that if we can say segment AB is similar to segment WX, and we could say ZY is similar to DC using that color-coded ordered system. Just like I told you guys when we wrote congruent statements back in chapter 4 when we were dealing with congruent triangles. So it's kind of a handy trick to have in your book. Not necessary, but it is a handy trick to know. So, if triangle ABC is similar to RST, list all pairs of congruent angles and write a proportion that relates the corresponding sides. So, a couple things to highlight here. One, this symbol right here up on the top means similar. You'll see that a lot in the upcoming lessons. So, important to know that that means similar. Now, our congruent angles are going to correspond in our similarity statement. So, right away, I can say angle A is congruent to angle R because they're in the same relative position. I can say angle B is congruent to angle S, and I can say angle C is congruent to angle T, all because of how they wrote that similarity statement. And also we can tell by looking at the picture, but we know that pictures aren't always drawn to scale, whereas the similarity statement is always deliberately made so that we can show which angles are congruent and which sides are similar. Now, the second piece of this is they want us to write a proportion that relates the corresponding sides. Now, I'm going to write one big proportion. However, you can write these all individually as well if you so choose. So, I'm going to say AB, AB over RS is proportional to BC over ST, and last but not least, AC over RT. So if we look at this in terms of our congruent statement, AB and RS are the first two points in each of these similarity statements. BC and ST are the last two in each in the similarity statements, and then AC is the first and the third, and RT is the first and the third in their respective similarity statements. So the order does in fact matter in these. And this is just another example showing how that matters. And once again, I really like how they color coded it. So if you wanted to put this in your notes, it would be a good thing to have in your notes. All right. So if triangle GHK is similar to PQR, determine which of the following similarity statements is not true. So angle HGK and QPR are congruent. That would be true. GH over PQ equals GK over PR. That would be true. Angle K is congruent to angle R. I would agree with that. And angle GHK is congruent to angle PQPR. So they're saying this angle and this angle are congruent. So that one would not be true. So our answer is D. All right, continuing on. So Tan is designing a new menu for the restaurant he works. Determine whether the size for the new menu is similar to the original menu. If so, write the similarity statement and scale factor. Explain your reasoning. So the original menu is 10 by 12 and the new menu is 12 by 14. So on the next page, we're going to work through this. So what we need to do is we need to figure out if these menus are proportional. And how we're going to do that is we are going to set up a proportion. And so for me to set up that proportion, what I'm going to do is I'm going to take side AB, which is 10 inches, and I'm going to set that over side FG, which is 12 inches. And I'm going to set that equal to side AD, which is 12 inches, over side FH, which is 14 inches. So what we need to do is we need to figure out if this is in fact proportional. And so to do that, what I'm going to do is I'm going to cross multiply, which will give me 140 equals 144, which those do not equal, which means it is not proportional, which means it is not similar. I think I spelled similar wrong. No, I did. I spelled it right. Look at me. There is another way that you can do this. If you would like to, you can set, or not set equal, you can reduce each of these fractions. So if I reduced 10 over 12, I would get 5/6. And then if I reduced 12 over 14, I would get 6/7. So these would be their perspective scale factors, and these would need to be the same if it was similar. And so since 6/7 and 5/6 are not equal, then we do not have a similar polygon. All right, so this is one that you would try on your own, but we're going to do it together since this is the video and not the actual lesson. So once again, I'm going to set this up the same way. I'm going to do BC over FG, which would be 8 over 16. And I'm going to set that equal to BE over FI, which would be 6 over 12. Now, once again, we can do this either way. So I can do 8 times 12. I could do that if I could turn my calculator on. That would be helpful. So 8 times 12 is 96, and 6 times 16 is also 96. So we know that these are, in fact, similar. Now we have to find the scale factor, which, like I said in the last problem, we do that by reducing these fractions. Or you can just divide them in your calculator. So you could do 6 divided by 12, which would give you 0.5, which we know is a half, but then you could hit the, I believe, second PRB, which should have like a F D above it. And that will convert it to a fraction, but we could also just reduce 6 over 12 to 1/2 because that's not too wildly terrible. All right, so they tell us two polygons are similar. Find x and y. So the nice thing about this is if we look at the angles, A and R are similar, S and B are similar, or congruent, T and C are congruent, D and U are congruent, and E and V are congruent. So they have these shapes oriented the same way, which makes our lives a lot easier because we can just look at them straight across to see which ones are, which sides are corresponding. So since RS is in the top left and AB is in the top left, we know they're corresponding since these shapes are oriented the same. That being said, for us to find x and y, we're going to have to set up some proportions. And the nice thing about this problem is they give us RS and AB right off the bat that are proportional. So I can set those up, and using those, I could determine a scale factor. So I could say this smaller one, this smaller polygon is going to be 2/3 the length of whatever the length is on the bigger one. Or I could say that the bigger one is going to be 1.5 times the length if I set it up as 6 over 4. So I could say whatever the side length in the smaller one times 1.5 is going to be that bigger length. And that's one way to do it. Or you can set up a proportion and you could say, okay, 6 over 4, big one over little one, AB over RS is equal to DC over UT, which would be X over 3. And we could solve this out. We would get 18 equals 4x, and we would get x equals, that was x, correct? Yeah, x equals 4.5. So you could do it that way as well. But anyway, so x equals 4.5, so we're part way there already. Now using that same 6 over 4, I'm going to say 6 over 4 is going to be equal to, the big piece of this bottom line is 8, and then the corresponding would be y plus 1. So I'm going to say 8 over y plus 1. And likewise, again, I could say side VU is going to be 2/3 of side ED, or side ED is 1.5 times side VU. But for this one, I think the easier way to do it is, in fact, cross multiply. So 4 times 8 would be, oh no, where'd it go? Anarchy. There we go. Nope, come back. So we got 32 is going to equal 6y plus 6. Then we reduce this, and we would get 26. Yeah. 6y equals 26. Nope, typed that in wrong. And so we would end up with y equals 4 1/3. And that's all there is to that. Alright, so you'd be responsible for solving these on your own, but we'll do them together real quick. The two polygons are similar. Solve for A. So I know A over 4 is going to be equal to, my big hand's getting in the way, 3 over 5. Don't know why I put another equal sign. Probably because it's cold and my brain's not working. So A equals 12. Sorry, 5A equals 12. Divide by 5. So A equals 12/5, or 2.4. So C. Continuing on, we're going to solve for B here, which we'll set up the same way. We'll say 3 over 5 equals 2. B minus 6 over 3, or I'm sorry, over 2. So we go about this, we get 6, we get 5b minus 30, and 5b equals 36, which would be 7.2. See? Lovely, lovely, lovely. So perimeters of similar polygons. If two polygons are similar, then their perimeters are proportional to the scale factor between them. So this would be a quick way to calculate perimeter if necessary. So if ABCDE is similar to RSTUV, find the scale factor of ABCDE to RSTUV and the perimeter of each polygon. So scale factor is nice and easy. We can say it's 7/4 because we have 7 over 4. And now the tough part is we do have to calculate the perimeter of one of these, which means we're going to have to set up at least one proportion. And the proportion I want to set up, 7 over 4. And then I'm going to set that equal to unknown, or x, over 6. Now, go about solving this. We get 42 equals 4x. And then 42 divided by 4 would be 10.5. X equals 10.5. So, that's weird. That's kind of strange. Did I mess something up? Or am I just losing my brain a little bit? No, that's correct. So x would be 10.5. So we got 10.5, 10.5, 10.5, and 7. And now we would have on this one, we would have 4. And then we know that these three sides are the same, so these three must be the same, 6, 6. So our perspective perimeters are going to be 26 units. And we could say 7/4 equals unknown perimeter over 26. We can set it up that way. And we would find out that this perimeter is 45.5. The other thing we could do is we could add up all the sides on this right one. 10.5 times 3 plus 14, and we would get 45.5. So, works out either way you look at it. All right, now this one you'd be responsible for on your own. However, we'll work it out together since we are here. Now, right away, I see the scale factor between these. This little one is going to be 3/4 as big as the big one. So, good news is we can find the perimeter of this big one real quick. Since we know this side's 16 and we know this one's 8, we can just add all those up super fast. And our perimeter of that big one is going to be 60, and we know, well, we know a few things. One thing, D is the only answer with a perimeter of 60 in it, and 2, 3/4 of 60 is going to be 45, so D is really just our best answer all around. If you have any questions,